Hello students, today we are going to see 8051 microcontrollers fourth chapter, which is interfacing and serial communication. So in there are different types of interfacing. That means we are connecting different type of devices to a 8051 microcontroller like ADC, analog to digital converter, DAC, digital to analog converter, and LCD display, stepper motor. All these devices are connected to 8051 controller. Okay, so in this chapter we will see how these all these devices are connected to 8051. Okay, so before going to interfacing, there is one more concept which is serial communication. Okay, so what is mean by serial communication? So we know that communication means exchanging the information. Okay, so if we exchange some information to each other, then it called as a communication. Okay, so similarly 8051 microcontroller and the devices which are connected to the 8051 are communicate to each other. Okay, so we know that analog to digital converter ADC. So we connect the ADC to a 8051 microcontroller. We connect DAC to 8051. Okay, so when we connect all these devices to 8051, the 8051 can be communicate to these devices. Similarly, these devices also communicate with 8051. Okay, so there is a exchanging the information between controller and these input output devices. Okay, so how the controller or these devices communicate to each other. So communication between controller and devices can be seen through this article. Okay, so programming serial port without interrupt. So 8051 support a synchronous type of serial communication. For this purpose there is a separate serial communication unit. So for communication purpose, there is a separate serial communication unit in 8051 microcontroller. So it is possible to set the baud rate of serial data transfer through a programming. So baud rate. So we know that baud rate. So baud rate means the rate at which information is transferred in a communication channel. So baud rate is commonly used in electronics that use serial communication. So in the serial communication port, if the baud rate is 9600, if we consider the baud rate of particular serial communication port is 9600, which means that the serial port is capable of transferring maximum 9600 bits per second. Okay, so baud rate represents the rate at which communication or information can be transferred from transmitter to receiver. Okay, so there are two pins, TXD or RXD. TXD stands for transmitter and RSD stands for receiver in serial transmission and reception of data bits. So in this article we are dealing with interfacing 8051 serial port with a COM port. COM means communication port of the PC. So the standard PC baud rate are 110, 150, 300, 600, 100 and 200, 200 and 2400, 4800, 9000 and 600, 19200. So these are the typical baud rate of any PC. Okay, so use of timer for setting the baud rate. Okay, so in previous chapter we saw the timers and timer programming. Okay, so we know that there are two timers, timer 0 and timer 1. Okay, so these two timers are also used for the communication purpose. Okay, so to set the baud rate for serial communication, microcontroller use timers. Okay, so baud rate in 8051 are programmable with the help of timer 1. Okay, so there are two timers, timer 0 and timer 1 in 8051. So only timer 1 is used for serial communication purpose. Okay, the function of this timer 1 in serial communication is to set the baud rate. Is to set the baud rate. Okay, timer 1 is used in mode. 2. The following table show the baud rate and the value to be stored in a th1. Okay, so we know that there are two timers of 8051 microcontroller, timer 0 and timer 1. So out of these two timers, only timer 1 is used for serial communication purpose. Okay, now there are four modes of operation: mode 0, mode 1, mode 2 and mode 3. So out of these four mode 2 is used for a baud rate. Okay, so timer 1 and mode 2 is used for serial communication purpose. Okay, and the function of timer is to set the baud rate. Okay, and baud rate is the rate at which the data is transferred from transmitter to receiver. Okay, so here the one table is given which represent different baud rate and the value to be loaded in th1 register. So we know that th1 register is the higher bit of timer 1. Okay, so if the baud rate is 9600, then we put the -3 value in th1 register. So -3 is a decimal, and in hexadecimal -3 can be represented as fd. For 9600 baud rate, the th1 register is loaded with -3 value in decimals, and in hexadecimal -3 is represented as fd. Okay, similarly for 4800 baud rate, the th1 register is loaded with -6 value, Okay, so this -6 is the fa in hexadecimal number system. Similarly for 2400, the -12, this value can be loaded in th1 register. Okay, and -12 can be represented in hexadecimal, which is f4. Similarly 1200 -24 can be loaded in th1, and f8 is a hexadecimal value. Okay, so you have to remember this baud rate table. Okay, so for 9600, -3 value is loaded in th1. For 4800, -6 value load in th1. For 2400, -12 loaded in th1, and for 1200, -24 loaded in a th1 register. Okay, so the 8051 divide the crystal frequency by 12 to get the machine cycle frequency. So this is, we know that this we saw in chapter 3. So we divide the crystal frequency by 12. So after dividing the crystal frequency by 12, we get the timer frequency. Okay, so the 8051 is a UART, that means Universal Asynchronous Receiver Transmitter. The full form of UART is Universal Asynchronous Receiver and Transmitter. Okay, so further divide this frequency by 32 to be used with timer 1 for the setting the baud rate. Okay, so the timer TI will always be set in mode 2. That's it, 8-bit auto reload. Okay, so once we so in chapter 3 we saw that we divide the clock frequency by 12, then we get the timer frequency. Okay, similarly for serial communication purpose we require some frequency. Then how we get this frequency for serial communication? So we divide the crystal frequency, that means which is a controller frequency, crystal frequency, by 12. Okay, then we get timer frequency. Okay, then we get timer frequency. Okay, so again this timer frequency is divided by 12, sorry, 32. This timer frequency divided by 32, then we get serial communication frequency. Serial communication frequency. So crystal frequency, which is a microcontroller frequency. So this microcontroller frequency divided by 12, then we get timer frequency, and this timer frequency again divided by 32, then we get serial communication frequency. Okay, so the timer T1 will always be used in mode 2. Okay, so we use timer 1 mode 2 for serial communication purpose. Okay, now the next is SBUF register. So SBUF stand for serial buffer register. The full form of SBUF is serial buffer register. Okay, the SBUF register is the 8-bit register used for serial communication. The data that is to be transmitted via line should be placed in the SBUF register. So the received data is also stored in SBUF register. The information that we transmitted from transmitter to receiver, this information can be placed in SBUF register. Then this SBUF register can be transmitted from transmitter to receiver. So the function of this SBUF register is to store the information which is to be transmitted. Once again, I am telling the function of SBUF register is to store the information which is to be transmitted from transmitter to receiver. Okay, then SCON register. So SCON register stands for serial communication register. SCON register stands for serial communication register. The SCON register is an 8-bit register which is used to program the start, stop and data bit. Okay, so this serial communication register control the function of serial communication. Okay, so the following is the function of this XCOM register: SM0, SM1, SM2, REN, TB8, RB8, TI and RI. This is the 8-bit data frame of SCON register. Okay, so bit of SCON register is a bit addressable. So SM0, SM1 is the serial port mode specifier. SM2 is used for multi-purpose communication, usually 0. So this SM2 bit is usually a 0. Okay, and SM0 and SM serial port mode specify. That means this SM0 and SM1 is used for mode selector. Okay, so we know that we require mode 2. REN. So REN, this is the set reset by software or enable disable reception. So REN, this is the fourth bit which is set and reset by software. TB8, not widely used, keep it 0. Okay, RB8, which is also not used, keep it 0. See these two bits, TB8 and RB8 is kept 0. Okay, then TI and RI. TI is the transmitter flag is set by hardware at the beginning of stop bit in mode 1 must be clear by software. So TI and RI. TI means the transmitter interrupt and RI means receiver receive interrupt. Okay, so this is which is set by hardware at the beginning of a stop bit. So set by hardware at the beginning of stop bit in mode. So this bit become 1. This bit become 1 when all the information transmitted successfully. All the information transmitted successfully, then this TI flag become 1. Okay, so when the information is transmitted at the time of transmission, the TI flag is this TI is 0. So when information is transmitted completely, then it become 1. So this when TI flag become 1, then it represents that all the information transmitted successfully. Similarly, RI. Okay, so transmitter transmit the information. Then the function of receiver is to receive the information. Okay, so when receiver receive the information, this RI bit is 0. When receiver receive the information, this RI bit is 0. And whenever the reception is completed, that means receiver receive all the information completely, then this RI flag become 1. So when RI flag become 1, then it indicate that the information, all the information received completely. Okay, so in this way SCON register is work. Okay, so here SM0 and SM1. So here SM0 and SM1 is a mode specifier. Okay, so there are four mode. So SM0 and SM1, 0 then it is a serial mode 0 1 then it is a serial mode 1 then it is a serial mode 2 then it is a serial mode 3. Okay, mode 0, mode 2 and mode 3 are rarely used. Mode 1 is widely used and it's compatible with comport IBM compatible PC. So we use only mode 1. We use only mode 1. Okay, for serial communication purpose. Okay, so we use only mode 1. Then SM0 and SM1 is 0 1 okay, and return is set reset. Okay, set reset. So it set, that means it become 1. So the number is 5. So the number is 5. Okay, and these bit are initially 0. These bit are initially 0. Why initially 0? Because TB8 and RB8 are not used. It keep it as 0, and TI and RI is initially 0. When transmitter transmit the information completely, then and then only TI become 1. Otherwise TI is 0. Similarly RI. When receiver receive all the information completely, then and only then RI become 1. Otherwise it is 0. So initially TI and RI both are 0. Okay, so 0 0 0 it represent 0. So 50 value stored in SCON register. So 50 value stored in SCON register. So this means that the SM0 and SM1 is for mode 1. Okay, so we use SM0 and SM1 for is used for mode selector. So these two bits are 0 1. So that means the mode 1 is selected, SM2 is 0, return return is set. That means this transmitter is ready to transmit the information. Then TB8 RB8 these two bits are not used, so these two bits are also 0, and TI and RI are initially 0. So the value becomes 50. So 50 value can be stored in SCON register. Okay, so when we load SCON register with a 50 value, then microcontroller will understand that the mode 1 is used for a serial communication purpose. Okay, so here the return bit allow 8051 receive data on RSD, that means a receive line, if it's set high, if a 0 reception is disabled. So when return bit is 1, then the receiver is ready to receive the information. Otherwise, when RN bit is 0, then receiver cannot receive any information. Okay, so RN bit is 1, then receiver receive the information. Otherwise, it cannot be receive any information. Similarly, TI is raised to 1 when 8051 finish the transfer of data. So TI become 1 when 8051 transmit all the information. Otherwise it is 0. Similarly, RI is set to 1 when 8051 receive complete information. Receive the complete information. The RI bit is set by 8051 when serial byte of data has been placed in SBUF. The 8051 remove the start and stop bit before placing the character byte into the SBUF. Okay, so how we transmit the information? Okay, so suppose we want to transmit 1011. So this is our information. This is our information. So after this information we add one more bit, which is a start bit, which is start bit. And so first this start bit is sent. Okay, then the data is sent. Then after data is completed, then one more bit is sent, which is the stop bit. Okay, so 1011. So this is our 4-bit data. So before this bit there is one more bit which is called as a start bit, and after that this 8-bit data, there is one more bit which is called as a stop bit. Okay, so if we consider the information 1 1 0 1 1 1. Okay, so this is the information. So out of this information, this 4 bit is a data bit. These 4 bits are a data bit. That means this 4 bit represent information. This one represent, this is the start bit. This is not a data or not a information. This is the start bit. This start bit indicate that the information is a transmitted. The transmission of information is started. Transmission of information is started. And this one is called as the stop bit. This stop bit indicate that the transmission of information is finished. Transmission of information is finished. Okay, so therefore we add start bit and stop bit. Start bit indicate that the transmission is started, and stop bit indicate that transmission is completed. Okay, now here are some programming steps for serial communication. So serial data programming with 8051 for transfer of data. So these are the programming steps for transferring the data, for transmitting the data. Okay, so the T-mod register is loaded with value 20H. So T-mod, so we put the 20H value in T-mod register. So 20H means that timer 1 and mode 2 is used. Then the second step is th1 is loaded with one of the value -3, -6, -12, -24, which is depend on which baud rate we have to use. Suppose we use a baud rate 9600, then we use -3, and if we use the baud rate 1200, then we use -24 value to be loaded in th1 register. Okay, the ESCOM register is loaded with value 50H. How 50H? Here we explain. Here I am explaining why 50H. Why we put 50H value in ESCOM register. Okay, the first step is load the TMOD register with 20H value, which represent that timer 1 mode 2 is used. Then TH1 is loaded with loaded with one of the value -3, -6, -12, and -24, which are the base, which are based on which baud rate we have to use. Okay, then ESCOM register is loaded with value 50H. Okay, then TRI is set to 1, that means start the timer by set bit TR1 instruction that we saw in chapter 3. So TR1 is set to 1, that means this indicate that timer is started. Okay, then TI flag is clear with a clear TI. That means, so when we clear the TI flag, which indicate that the transmission is completed. Transmission is completed. When TI is equal to 0, when TI is equal to 0. So this indicate that the transmission of information is in process. Transmission of information is in process. And when ti is equal to 1, which indicate that transmission is completed. Okay, then SBUF register is loaded with a character to be transmitted. Then the data or the information that we want to transmit, it should be placed in SBUF register. Okay, then monitor TI flag with the instruction JNB. So once it come out of the loop, next character to be transmitted. Okay, so these are the programming steps. So let's start with the programming. So after seeing the example, the idea become clear. How the serial communication is done in 8051. Okay, so let's take one example. Write a 8051 C program to transfer a letter Y serially at 2400 baud continuously. Use 8-bit data and one stop bit. Okay, so here we have to transmit a letter Y, and we have to use baud rate 2400. Okay, so we know that serial clock frequency is 28,800. So you have to remember this serial communication frequency for 8051 microcontroller. So the 8051 microcontroller serial communication frequency is 28,800 hertz. 28,800 hertz is the serial communication frequency, and baud rate is a 2,400. Okay, okay. Now we have to calculate the value which is to be loaded in th1 register. So we divide this frequency. This is the serial communication frequency. So we divide this serial communication frequency by a given baud rate here. 28,800 divided by 2,400. So we get 12. We get 12. Okay. So we load the value 12 in th1 register. We load the value 12 in th1 register. So how we load the value in th1 register? So given baud rate is divided by the given baud rate is divided the serial communication frequency, and the serial communication frequency is 20,800 here. So 28,800 divided by the baud rate, then we get 12. So this 12 value is loaded in th1 register. Okay, so let's start program. The first step of the program is load tmod register with 20h. Okay, so here hash include reg51.h. This is the header file of 8051. Void main void. This is the main function. Okay. Then the first step of programming is load tmod register with 20h value. So here we done the first step. Tmod is equals to 0 cross 20. Then the second step is th1 is loaded with out of minus 3 minus 6 minus 2 minus 24. Out of this one value to be loaded in th1. So here th1 is loaded with minus 12. Why minus 12? Because the serial communication frequency is 20,800 and baud rate is given, which is 2,400. So 2004. So we divide this 2,400. So this baud rate is divide the 28,800. So it get 12. So this 12 value is loaded in th1 register. Okay. Then for the next is scon register is loaded with 50h. So here scon register is equal to 0 cross 50. Okay, all these three steps are done. Then the fourth step is start the timer. So TRI is equal to 1. This indicates that timer 1 is started. Okay. Then the Y letter we want to transmit. Okay. So that this Y letter is loaded or placed in a SBUF register. Okay. Then when we place any data in SBUF register, then transmission is beginning. Okay, so while ti is equal to 0, so this instruction indicate that transmission is in process. Transmission is in process. Okay, so whenever transmission is done, when the transmission is done, this ti bit, this ti become 1. This ti become 1. So when this ti become 1, it indicates that transmission is done. When ti is equal to 0, that means transmission is in process, and when ti is equal to 1, it indicates that transmission is done. Okay, so ti is equals to 0, character still being sent. Okay. Okay, so after sending the character ti is equal to 1, this indicates that transmission is done. Okay, then the next instruction is ti is equals to 0. So one character send ready for next character. So this information indicates that the one character is sent, and it is then the transmitter is ready for sending next character. Okay, so this is the 8051 C program for transmitting the information. Okay, so similarly, we can transmit the hello world. Similarly, we can transmit the hello world. Just to go through this program. Okay, the programming steps are similar for all the program. Load tmod register with 20h value, scon with 50h value, th1 with a particular baud rate, then timer tr1 is equals to 1, which indicate that timer is started, then while put the information in sbuf register, then it monitor the ti flag. When ti is become 1, then it clear by the instruction ti is equals to 0. Okay, all steps are same. Okay, similarly, there is one more program which is used for receiving the data. Okay, we write one program here which indicate that we transmit the data. Now for receiving we write another program. Okay, so now here the some steps which are used for receiving the information. So programming step to 8051 to serially receive a data. Okay, load tmod register with 20h value which indicate that timer 1 and mode 2 is used. th1 is loaded with appropriate value is set to baud rate. So th1 is loaded with a particular value which is depend on which baud rate we have to use. Then scon register is loaded with 50h value. Then tri is set, that means to start the timer. Then ri is clear with instruction clear ri. Ri flag is continuously monitored. If ri become 1, it means that sbuf has the data. Okay, so to receive next byte, ri clear ri and proceed again. Okay, so when timer is start, ri flag should be clear. That means ri flag is equal to 1, which indicate that the receiver receive the information. So receiving information is in process. So ri flag is continuously monitor. Why monitor? Why we monitor the, why controller monitor the ri flag? So when ri flag is equal to 1, that means reception is in process. Okay, so therefore ri flag is continuously monitored, and when ri is become 1, which indicate that receiving information is completed. Okay, okay, then for next round we clear the ri flag. We again clear the ri flag, which indicate that we have to receive, which indicate that receiver receive next information. Okay, so let's see all these programming step with example. Okay, so write 8051c program to receive byte serially and send them to p2. Set baud rate 9600. So for 9600 the value is minus 3. How we calculate this minus 3? The serial communication frequency 28,800 is divided by the given baud rate. Then we get minus 3. So for this 9600, the value is minus 3 that we saw in previous table. For 9600, the value is minus 3, which is to be loaded in th1 register. Okay. Okay. And tmod register is 20h, which indicate that timer 1 mode 2, and scon register loaded with 50. Okay, so hash include h51.h. This is the header, uh, this is the header file. Then void main void, this is the main function. Then the first step is load the tmod register. Here we load the tmod register with 20h value. Then the second is scon register. Here we put xcon, here we put 50 value in scon register. Then th1 is minus 3. Then tr1, the fourth step is tr1 set to 1 to indicate that timer is start. So tr1 is equal to 1. Okay, all these steps. Then here we use the while loop. Okay, so while ri is equal to 0, so the meaning of this instruction is that the receiving information is in process. That means receiver receive the information. So when a receiver receive the information, ri is 0. So this 0 indicate that the receiving information is in process. Okay, then AP2 is equals to SBUF. So we know that the information is SBUF register. So here the SBUF, the information stored in SBUF register is given to the port 2, because here in program mentioned that receive the byte and send to the P2. That means we receive the information, and this received information can be saved in P2 port. Okay, so we know that here the ri is equals to 0. That means the receiver receive the information, and this information is in sbuf register. Okay, so Now this instruction indicates that the information stored in SBUF can be saved in P2 port. Okay, then RI is equals to 0. That means RI is equals to 0 means we clear the RI flag for receiving next bit. For receiving next bit. So in this way 8051 communicate to other devices, or it can be done serial communication. Okay, so just to go through all these program, the programming step uh, are same. Just go through this program. Okay, now we will stop here. Now in next lecture we will see the interfacing, ADC interfacing, DAC, LCD and stepper motor interfacing. Okay, now we will stop here.